Alrighty, without further ado, I give you division as partitioning. Division as partitioning. This lesson is going to come to you from Miss Thaxton today. Please make sure that you ask questions as they come to you. If you are not asking questions, this will not make much sense, okay? So I am expecting a lot of questions. I am hoping for a lot of questions today. Questions tell me that you're actively thinking about the information and want it to make sense. So ask me questions and make me happy, all right? Okay, here is our success criteria review.
Today's learning target is to represent the concept of division of whole numbers using partitioning. Now, partitioning sounds like a big word, but it's really just a word that you already know. It is a word that means to take something whole and to divide it or break it into smaller parts. You can see there's a couple of pictures here. There's a picture of the food. Let's take a look at the pie. In the pie, you can see that it has been divided into or cut into 1, 2, 3 parts. Partition just means that it's been partitioned off or divided off into smaller parts. Take a look at the next picture here. It looks like maybe a bank, and there's a whole counter there, and what they have done is put up partitions to divide off that counter into smaller parts, probably due to COVID. And then here you can see there's a bathroom, and it was one whole room to begin with, but then they put up partitions to divide the room into smaller rooms so that you would have privacy. And in the last picture, we can see another picture of Play-Doh, where they took a whole piece of Play-Doh and they cut it into smaller.
All right, so are we all clear that the word partition just means to divide or cut? It's a fancy way to cut or to divide something, okay? You can partition pretty much anything in the world. We saw in that example, if it'll let me go back here, we saw in that example that you can partition a room, like a bathroom. You can partition a counter with dividers. You can partition Play-Doh by cutting it apart. You can partition food by sharing it. So partition, fancy word for divide.
They cut it into smaller parts. So let's see how that would look with division. Thinking about if we had a candy bar and we had one candy bar and we wanted to share it with 4 friends. Well, we can see in this candy bar, it's kind of easy because there are 4 pieces. 1, 2, 3, 4 pieces and 4 friends. Okay, so each friend then would get 1 piece of the candy bar. Pretty simple. Okay, but then what happens if we have a larger candy bar and we still want to share it with our 4 friends? You might look at that and think, well, it could still be pretty simple based on how it's been divided. We could just cut this right here, here, and here, or partition it, and give each friend 3 pieces. 1, 2, 3 pieces for this guy. 1, 2, 3 pieces for her. 1, 2, 3 pieces for him, and 1, 2, 3 pieces for her. So we take one candy bar, and instead of breaking off 1 piece, we're going to break off 3 pieces at a time to share, because it's a little simpler and easier to manage rather than breaking off 1 piece at a time. Okay, but here, that's where it's really going to get tricky. If we have a candy bar that's this big, what on earth are we going to do? What might be the best way to divide out this candy bar? On this page, I would like for you and your teacher to come up with a couple of ways that might be an easy and quick way to share this gigantic candy bar with the 4 people equally.
Alrighty, so I want to show you that candy bar again. This candy bar is humongous. And if we're going to share it with 4 people, something that might help us is to know how many pieces are on that candy bar. So I've counted up this candy bar, and this candy bar has 168 pieces on it. Now, 168 is going to take a long time to count if we're counting like 1, 2, 3, 4, 1, 2. That's going to take forever. Okay, so the question is, what would be an easier way for us to divide this candy bar, to cut it up? Are there any ideas out there so far? Christopher, what do you think?
By 10 to 3, if there's some extra, you can put one in each one.
Okay, so Christopher says by tens. All right, that's an idea. That's not going to take as long as counting by ones for sure. All right, thank you, Christopher. By tens. Any other ideas out there? What other ideas? Anton, what else could we do?
Divide it to 10 and take away the 8.
So you're saying do tens and then split up this 8? Okay, so by tens, then split the 8. Because you know the 8 isn't going to be split by 10. Okay, so Anton's given us an idea. Very good. I've got somebody unmuted, trying to see who it is. There we go. Okay, thank you. That way we don't have some background noise. What else could we do? Terrence, what else could we do?
So if you would go back to the chocolate bar, there's some big squares, and there's 4 of them.
Okay, so
when you go there, then there's 4 in each one, so you could divide them and see how many's in one, and then and then that will be how much is in the other one, because it's equal.
Okay, so Terrence is saying go by these big squares that we've got here, and we could see how many are in one. So inside of these squares, I already know this is 16 and this is 16, so it would be 32. So you're saying to count the chocolates and then go by 32. Okay, so Terrence says, Terrence says by the pieces of chocolate. So big squares of chocolate is what he said. Big square, you know what? I'm going to draw a square. That'll be faster. Big squares of chocolate. And we just discovered together that that is by 32s. Okay, nice. So Terrence's strategy is a bit more visual there. We'd have a visual to go by. What other ideas are out there? We are on a roll, people. Aiden G, what do you think? You're muted. There you go.
I think that you should count by 20s because it'll be more faster.
Okay, why would 20s be faster?
Because you can go 20, 40 until you get to 168.
So you are thinking that you're thinking that 10s might still be too slow because of how big this number is.
Mm-hmm.
Okay.
Or we can do 25s.
Okay, so 20s, maybe 25s. So you're saying go by a bigger number, divide by a larger section first. Is that right? Okay, he's saying move it on up. William.
So if you go back to the chocolate bar, I see there's like rectangles.
Uh-huh.
And then
go back to them. Right here, okay.
There's like rectangles, except they're in groups of 3. So there's 3 little candy pieces in each one, but there's 4. There's an array in each one. So there's 4. So there's 3 columns. There's 4 columns and 3 going across, and all going across there's 4. So there's 3 groups going like this, so you can count them in those groups.
First of all, sir, I think I just heard like 7 math vocabulary words in that explanation. Woo-hoo! Awesome. So yeah, he's recognizing that strategy of an array, and he's saying, look, if we did this bar by bar, each candy bar by each candy bar, we can just break off that section of 3. So section of 3 for first kid, section of 3 for the second kid, section of 3 for the third kid, section of 3 for the fourth kid, boom. And we could just do that until all of these smaller candy bars were passed out to each of the kids. Beautiful. Love that math vocabulary, sir. So William, let's see if we can capture that on our writing here. So William was saying, break the bar into smaller pieces of chocolate. Bar into, I'm going to use actually that math vocabulary you said, smaller arrays. Boom. All right, awesome. Okay. Other ideas? Leah, talk to me.
So what you could do is like make a big circle and put 100 in it, and then just put tens for the 60, and then just count 8 ones.
So you're saying by looking here, we can see that there's 16 tens and divide that. So you're talking about using place value to divide. Boom, that's a beautiful concept. So Leah knows that if we have 160, that can be broken into 16 tens, and then we can divide that between the 4 kiddos. Place value. My gosh, I did not expect this many ideas. Levin, give us a last idea, sir. What's another idea?
So you can actually count by the bars, the straight one line, then you keep going down by that number.
Okay, so let me go back to the chocolate bar here to make sure I understand what you're saying. So you are saying, there we go. So you are saying we can do this. Let me see if I got it right. Are you saying we can do this? One line for the first kid, one line for the second kid. Is that what you're saying? And then see, okay, so we could see that there are 4 here. There's 4 in that section. There's 4 in that section. 4 plus 4 plus 4 plus, oh, you guys see that repeated addition? You see that? Ooh, I told you you'd use it, is equal to 12. So Levin is suggesting we count by 12s, by just the rows of chocolate. Cut it, here's for you. Cut it, here's for you. Cut it, here's for you. Boom. So breaking it down into a friendlier view of rows. Y'all are on fire, man. My gosh. So Levin here is saying that we can break it down into rows. Okay, rows. And we found out that those were of 12. So that might be a practical way to do it quickly. If I have my knife, some for you, some for you, some for you. We're done, right? Beautiful. My gosh, look at all those ideas. Okay, let's see how Miss Thaxton chooses to solve with division by partitioning and see what ideas she came up with.
I bet you came up with some creative ways to share your candy bar amongst your 4 friends equally. Regardless of what your list looks like, I bet there are most of your ideas probably required breaking off more than one piece at a time. And that's kind of our concept today with partitioning, is to take larger chunks of our number, of our dividend, to break it off to share equally, excuse me, rather than just one piece at a time. So let's see what that looks like. So just like with the giant candy bar, we're going to take our larger dividend of 40 in this case. 40 is our dividend. And we're going to break it into 4 buckets. But instead of taking one at a time, one for you, 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 oh, that would take a very long time. Instead of doing it that way, what we're going to do is we're going to share chunks at a time. So let's see what that might look like. Okay, we could take groups of 5 and count by 5s. Let's see, 5, 10, 15, 20, 25, 30, 35, 40. That wasn't too bad. Quite a bit quicker than doing it one at a time. Okay, but let's try groups of 10, see if that's even quicker. 10, 20, 30, 40. Yeah. Well, when we take and we share 40 in groups of 10, well, that went very quick. All right, so that shows us that we've got one bundle of 10 in each bucket. So that must mean that our quotient is 10. 40 divided by 4 equals 10 because each bucket had 10 in it. Okay, let's try another one like that.
Are there any questions about why she chose to use tens as the fastest option? Any questions about that? Christopher.
It was not a question.
Oh, okay. Aiden G.
Why didn't she just use the 2 5? So why didn't she put 4 5s at the 2 other buckets at the end instead of putting the 2 10s?
So why did she switch from 5s? She was showing you that there's more than one way to solve. And also she was showing you that using the larger number got you the answer quicker. So 5s still worked, but I still had to put 2 groups inside of each bucket. With 10s, I only had to move 1 group. So it's just about kind of like you and your mom and I have told you, working smarter, not harder. Those 10s are going to get you going a lot quicker. Okay, so it's thinking about what's the fastest, most accurate way that I can do this. So 5s work, 10s work too, but 10s are faster. Does that make sense, or is that still confusing? Makes sense. All right, awesome. Let's keep going with another example.
Bucket had 10 in it. Okay, let's try another one like that. All right, 25 divided by 5. So now we have 25. 10 worked the last time. Let's try that again. Okay, so let me not use the pen. Here we go. 10, 20. Oh, let me move that to the front anyway. Here we go. Okay, so there's 20 if we have bundles of 10, but then none of the other buckets have any. Well, let me see if I can just put 10 here. 10 in this one. Oh, wait, but that's 10, 25. So we've already used 25. So I don't have any more because our quotient, as we can see, is 25. I cannot use more than 25.
So this wouldn't work for what she just said. You can't use more and you can't use less. And in division, it has to be equal. Each bucket has to have the same number inside of it. And if this one has 10 and this bucket has nothing, that's not division. It's not creating equal groups.
So that's 10 plus 10 plus 5 equals 25. And these 2 buckets do not have anything in them. So that's not going to work. Let's try putting 5 in each one of the buckets and see how that helps. All right, so let's take, goodness gracious. Let's take and move 5. So 5 here. Yeah, to the front. Sorry about that. 5 there, 5 there, 5 there. That's annoying. There we go. 5 there and 5 there. All right, so we used all our groups of 5. Let's make sure we have 25 that we've used all together. So we've got 5, 10, 15, 20, 25. Okay, and that matches our dividend of 25. So as we can see, we put 5 in each one of the buckets. So that means our quotient is 5. 25 bundle or 25 sticks all together divided into 5 buckets means that there's going to be 5 in each bucket.
All right. So That is how we use partitioning. It's the idea of using larger groups instead of one by one and dividing. What questions can I answer about partitioning? Any questions at all? Okay. So on your activities inside of Seesaw, you have dividing larger numbers using partitioning day 1. Go ahead and open that up inside of Seesaw now. And again, you'll want to make your screen smaller and put zoom next to your screen. That way you can see my work and your work at the same time. I'm going to leave my work larger so that it's easier for you to see. And we're going to click on that add response. As you are adding the response, I'm going to be reading the directions to you. Click add response to try some problems on your own. Use the bundles to divide the dividend in each equation given. On slides 4 and 8, circle the size of the bundles you chose on the previous slide. Then click the microphone to explain why you chose to use that bundle. On slide 9, move the emoji that best describes how successful you felt with today's learning target. Click the check when finished. So by now you should have opened up that response on your Seesaw work, and you should be looking at slide 1. Slide 1 is an example, just like you saw inside of your book work, where we are seeing, or in your video work, 50 divided by 5 is equal to what? Here's a little hint video from Ms. Thaxton.
Now it's time for you to give it a try. You have 50 as your quotient, and you're going to divide that 50 into 5 buckets. Use the bundles to divide the dividend equally. Try using groups of 10, then try using groups of 5, or you can try one at a time. Think about which way will get you there the fastest.
So let's talk about this. What's going to be the fastest way, do you think? Show me with your fingers. Is it going to be to use the 10s, the 5s, or the 1s? What's going to be the fastest way to get up to 50? 10s, 5s, or 1s? I have 3 people using their hands. Show me with your hands, kiddos. 10s, 5s, or 1s? Lots of 10s. Okay, I'm seeing lots of 10s. Let's try it. With me, go ahead and grab a group of 10 and put it in the first bucket. That's 10. Let's put one in the second bucket. That's 20. Third bucket, that's 30. Fourth bucket, that's 40. Fifth bucket, that's 50. I'm going to use my pen tool to count to make sure I have the correct amount. This is 10. I'd like for you to do that with me. This is 20. This is 30. This is 40. This is 50. So we have our dividend, so we are good to go. How many items are in one bucket? Well, inside of one bucket, we have 10 items. So our quotient is 10. There are 10 items in each bucket. Questions about that? Did we need to use the 5s? Do we need to use the 1s? Nope, we did not. We got it done very quickly, much more efficiently than going one by one by one by one by one until we got there. Okay, awesome. Let's take a look at slide number 2. Slide number 2 is the same with a different equation. We have to get to 40, and we only have 2 buckets. It's going to take me a really long time to go 1, 2, 3, all the way up to 40. That's going to take forever. I'm not going to use the 1s. I could use the 5s, 5, 10, 15, and I could do that. I could also use the 10s, I think, because my 1s place ends in a 0. And we know that that can be counted by tens. So let's try those tens again. Let's try to use those tens. 10, 20, 30, 40. Hey-oh, look at that. I'm at 40. There's 20 here, plus 20 more equals 40. How many are in one bucket? Well, I have two groups of 10. 10 plus 10 is equal to 20. So if one bucket has 20 in it, my quotient is 20. 40 divided by 2 equals 20. Questions on slide 2? All right. Let's take a look at slide 3. So on slide 3, we have 30 divided by 5. Now, you know what? This, I think, might be a good hint. There's a 5 inside of my equation. I could probably count by groups of 5. That's a pretty big hint to me. But let's start out with the tens. If I go 10 in the first bucket, 10 in the second bucket, and 10 in the third bucket, uh-oh, I'm already at 30 and there's nothing in the other two buckets. So I can't use tens. They're too big. So I'm going to have to put all those back. I'm going to use the backwards arrow to get those put back. Tens don't work. So let's go down to fives. 5 in the first bucket, so that's 5, 10, 15, 20, 25. I don't know why that one's there. I'm going to order it and put it in the front. Order, bring to front. There we go. 25. Okay. I'm at 25 so far. 5, 10, 15, 20, 25. If I use another 5 to get to 30, uh-oh, that's not going to be fair because this bucket is going to be missing those 5s. So I can't use another 5. So now I have to go down to my 1s. So now I'm going to take a 1. So I'm at 5, 10, 15, 20, 25, 26, 27, 28, 29, 30. So how many are in each bucket? 5 plus 1 is 6. So that is 6, 12, 18, 24, 30. Hey-oh, I am at 30. Yes. So there are 6 in each bucket. That means my quotient is equal to 6. There's a group of 5 and 1, 1 inside of each bucket. Okay. In my directions, there was something special about slides 4 and 8. So I'm going to look. On slide 4, circle the size of the bundle you chose on the previous slide, then click the microphone to explain why you chose that. Okay, so on slide 4, in the equation 30 divided by 5, I found it quickest and easiest to divide by. I used groups of 5 and 1 at a time. We used both. Here's my group of 5. Here's my 1 at a time. So we used both. My directions told me to use the microphone to explain why. So I'm going to do that. In the equation 30 divided by 5, I found it quickest and easiest to divide by groups of 5 and 1 at a time because groups of 10 wouldn't have or was too big. I wouldn't have had enough for 5 buckets. If I went 1 at a time, that would have been too slow. So I started with 5s, and then whatever was left, I counted by 1s. And there we go. I've explained myself, and here is my recording of my explanation. Okay? I'm going to go on mute. You go ahead and record yourself right now with the microphone, explaining why you chose to use 5s and 1s. So I'm going to go on mute. You record yourself. Go. Alrighty, I saw about 4 mouths moving. So I saw 4 people doing what they were supposed to. The rest of you are going to need to do that during your independent work time. Okay. Slides 5, 6, 7, and 8 are exactly like the slides we just practiced together, but they're going to be completed independently. Okay. So you are going to complete slide 5, 6, 7, and 8. You are also going to complete slide 9. After you've done your work, which way describes how you are feeling? Your directions say to drag the emoji to how successful you feel about the target. It also says right here to click the record button to explain your choice. So you're going to record your voice saying why you feel that you've got this, that you're almost there, or that it was very difficult. Okay?